Okay, this video is about electrorefining and electroplating. These are two things which are stipulated on the Year 12 ATAR syllabus. They're actually not really particularly different to electrolysis or electrowinning. So the two processes, electrorefining and electroplating, they require the input of electrical energy, and that drives a non-spontaneous reaction. And then the setup of the cell itself actually produces the desired end result. So, let's have a look at electrorefining, and specifically electrorefining of copper is the process which is stipulated in the syllabus. So electrorefining of copper is necessary for some end uses for copper. When copper is made, it's done by a process called smelting, which is essentially roasting the copper ore and then reducing it to the metal. The metal that's produced, the best that you can probably get it is only around about 98% pure, and for some end uses that's just not not good enough. So there are typically impurities such as silver, platinum, iron, and nickel. And these impurities, the process of electrorefining actually gets rid of them. Now that relies on the strength of these as oxidants, and we'll see sort of that process in a little while. So as I say, the end use, the typical end use for requiring really pure copper is in types of electrical wiring, and to obtain the super pure version of copper, then this process called electrorefining is actually used. Now, it's not dissimilar in nature to electrowinning or electrolysis. So the cell which is used to carry it out will appear quite familiar, and this is the cell coming up in a little while. So the process involves the oxidation of the anode, which would, in the case of electrorefining copper, be the impure copper. So the impure copper is oxidized, so electrons are lost, and it becomes the ion, and that enters the electrolyte. Now, in electrowinning or electrolysis, the anode is inert, so it's typically graphite or another inert material. But in electrorefining, it actually takes part in the reaction, and that's what we want to happen. So here is a schematic of the cell, and you should be able to see here it looks quite similar to the electrolysis cell that you saw in the previous video. So the battery here provides the EMF, and this is the negative terminal of the battery, which pumps electrons this way. So this becomes the cathode, and at the positive terminal will cause this to be electron poor. So what's going to happen is this would be the impure copper, and electrons will be pulled away from it to form copper ions. Now the electrolyte itself is a solution of acidified copper sulfate, and you'll see how this actually interacts when we get down to the reactions themselves. So the other thing to remember is that in the impure anode, we've got these impurities: iron, zinc, copper, nickel, and also things like silver. And so if you look at the position of these in the periodic in the standard electrode potential table, the standard reduction potential table, sorry, they appear below copper. So what's going to happen is the battery is going to supply electrons. Sorry, it's going to pull electrons from the anode, and it's going to cause the impurities and the copper to lose electrons and become ions. They enter the solution. The electrons then go around the circuit, and the cathode therefore becomes electron rich. The copper, which appears high up in the standard reduction potential table, is the strongest oxidant of all of these ions, and so the reduction of, the copper ion is the weakest reductant, so it requires the least amount of energy to be converted back and reduced back to the metal. So the copper preferentially will deposit on the cathode and become the copper metal again. Now, as long as the voltage supplied by the battery is kept below a certain threshold, none of these ions will actually have enough energy supplied to them to be subsequently reduced, and so they will stay in solution. Things like silver simply fall away, and they will drop to the bottom, and this is called an anode sludge. Now the anode sludge contains metals such as silver, gold and platinum, and these are extremely valuable. So when an electrorefiner actually refines copper, they use processes to actually reclaim the silver, the gold and the platinum, and then they sell those on, and they actually make more money from that than actually selling the pure copper. So it's a nice little sideline for them. Electroplating is a similar process, and again one of the electrodes takes part in the reaction. So in the case of electrorefining, remember that the anode is actually being oxidized, and then the copper is being reduced back onto the cathode. In the case of electroplating, what happens is we would take a metal which has desirable properties but might be quite expensive, and we'll plate that onto another one. So an obvious example of that is silver plating. So what does that setup look like? Well, in the case of electroplating for silver, what we have is a silver nitrate solution. We would have a silver anode, and then for our cathode we would actually place the item in the electrolyte that we want to be plated. And what will then happen is the silver ions will be reduced onto the item and form a very thin layer on top of it. That's essentially what electroplating is. So we've looked at electrorefining, electroplating, and if you have any questions on that, then we'll discuss those next lesson. Thanks very much.